So today, it's a review for the graphing test. And I'd like you to get your iPad in the notes and put a smiley face on it and turn it my way so I know that you're ready to go and you're not watching a YouTube video right now. Quickly, please. Smiley face on the notes. There you go. Make thicker markers so that when I ask you to turn it my way, I'll be able to read it. Waiting for you to make it fast, please. All right, thank you. All right, thank you. Good. Here we go. I'd like you to start with a equation that starts like this. Negative 2x to the fourth plus 3x to the third minus 2x squared minus 10. Make me a sketch that could be that equation. Then, for your follow-up to it, I'd like you to make me an equation that could be the equation for that, as far as you can tell from my sketch. Okay, so for this one, I want a sketch. For this one, I want an equation. Two separate problems. All right, I'll pause for a second while you give that a try. Okay, here's some thoughts of what I would have had if I were you. First thing, this, when you're sketching, is just flyover country. We don't care what that really does. Okay, but you should have noticed that's important. You hope you have it touching down here. All right. Negative 10 is the y-intercept, because the y-intercept is where x is 0, and that would cancel everything out, actually. But this beginning part is important, too. That negative tells me it's down on the right. And the fact that it's even tells me that both of them go together. So since it's down on the right, it has to also be down on the left. And then as long as it goes through here, I'd be good. Now, I don't even want to mess with your head that you wouldn't even have to have any real intercepts. Like you wouldn't even have to go above the x-axis, but I will mess with your head just a little bit. Do you get that that would only have imaginary roots if I did it that way? Is it humanly possible that it might only have imaginary roots? Yeah, it might. It could have 4 imaginary roots. But it's probably more likely that it did something like either this, which would have 2 real roots and 2 imaginaries, or it could have possibly done something like boing, boing. That's another way you could have got 4 roots. And let's see, how about up and then bounce and then back down again? Yeah, that works. That's a total of 1, 2, 3, 4 roots. Okay? All right, so there's some options for how that graph could have looked. Oh, what question? Oh, you're right. I couldn't have done it that way. Thank you. That had a y-intercept up here, and that wouldn't have worked. You're right. Thank you. So I could go like this, bounce, cut through, and then go through there. There we go. Now that's got, even if that's 2 cut-throughs, it still works because 2, 3, 4 roots. Or if it's a bounce, counts as double, counts as 4 roots. So, all right, so there's lots of options for those. This one, this red one, I'm hoping that you knew that it started with a positive number because it's going up on the right. And it really doesn't tell us anything about the stretch factor. We have no idea. But I'm going to put an x to the 2 plus 1 makes 3. Now, could I have a student argue with me and say that that could be x to the 5th? Yeah, because could be 2 imaginary roots. Remember that what they couldn't do is they couldn't say there's 1 imaginary root, because first of all, imaginaries are always, from the quadratic formula, we have plus and minus the square root of blah, blah, blah. There's always 2. There's always plus and a minus of the imaginaries. But if you wanted to argue that there was imaginaries, there could be. There could be 2 or 4 or 6 or 8 imaginaries, because this could be x to the 11th, as long as it's to an odd power. Then this is flyover country. I don't know what you put in here. Nope, not to the 5th. That would be bad. Second plus 5x minus, and then where does it touch? It looks like positive something, so plus 7. As long as you got a positive number at the end and an odd power right there, then I couldn't have marked you wrong for this.
What if you didn't have the 2x, like x?
You didn't have to have anything in here. I'm not going to grade that at all. You know what I'm saying? Because that could be anything. That's flyover country. You don't notice that.
You don't have to.
You don't have to put the what? Yeah, there's nothing needed in between. You can put it, you don't have to put it. All right, because this is just what could be the equation for this. And that could be, because I don't know what all the details are here. Now, if I really wanted to test you, I would have, in the directions, said, you must have appropriate roots. Now, do you get that then this must be like, let's say 2, and this must be like -1 as the roots? You know, it touches here and here. If that's the case, if I label that for you with a 2 and a -1, now write me the equation, because you can be much more specific if I tell you the roots. Try to write me the equation now. Miss N, what did you say? 2 sets of parentheses, I'm assuming? Good. X plus 1, that way this -1 would make it a root. Okay, then what?
X plus 2, and then
I'm not sure about the x plus 2. There you go, good.
and then squared.
And squared, that's the key right there. That bounce right there tells me that's a squared. Now, just to make sure, remember the y-intercept's important. I don't even know what it is, but I know it's positive. So would this one have a positive y-intercept? The y-intercept is where x is 0, right? So I could put in a 0 here and find out that it would be 1 times that squared, which would be, yeah, it's going to be a positive number. That would work. Okay. All right. Next topic for graphing is just plain old-fashioned graphing. Graph this. And I'm not asking you to sketch it, I'm asking you to graph it. I don't know if you remember, it's been a while, but we have a picture that you can insert. If you go insert picture, we took a picture of an XY axis so that you'd have a nice graph in your memory banks there on your iPad. So if you want to insert picture and insert that nice graph, now would be a good time for that. I'll pause for a second while you give this one a try. All right, if you're not done, just keep working, but I'm giving you enough time that most kids are done. So I hope you know the parent of this thing. The parent generally of 1 over x looks like this. Okay, now I'm going to be a little more careful as I draw it though than that, because there's asymptotes on it that look like this, and there's a key point here and here that go with these graphs. Okay. Now I'm going to move it. I'm going to move it 3 to the left. Notice that's going to take this asymptote. Oopie, better lock this in place. Locking, lock. And then I can move this alone 1, 2, 3 spots to the left. And then I should grab this and move it 3 spots to the left. And move this 3 spots to the left. Little arrows on the under, no big deal. Okay. Then up 5. Okay. Notice I'm going to have to move 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Move the asymptote up to 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. And that's about it. Okay. Now, let's say I had just made a major league brain fart, like I had just moved it right instead of left. I would never have known it. See what I mean? I think I did it perfect. How can I be sure? XY chart. Telling you. And I see how many kids I see that don't have an XY chart. It's like, okay, you're just totally risking it then. And on a test like this, especially on R3s, you make one extra mistake, a whole grade. Go from an A to a B, or from a B to a C. So take the time. Now, do I have to pick random numbers? No, I should actually pick strategic numbers. Like, I'm going to think, okay, that spot I think works, so I better put in -2. You get how I'm going to put in -2 on the X and see if it comes out right. -2 goes in here, and then I get 1, and then it's 1 over 1 is 1, and plus 5 is 6. Negative 2 goes with 6. And 1, 2, 3, 4, 5, 6. You see how I could catch myself like, oh, I didn't move it up 6. I moved it up 5 by accident. Or, no, sorry. Instead of moving it up 5, I moved it up 6. You can catch yourself on all kinds of little mistakes with this. Just one extra little step. Okay, so it's really smart. I'm curious, did any of you use an XY chart on this? Okay, one person checked theirs. Now I know it's a practice for the test, but on the test, I bet I'd only been 5. Your choice, your life, but if you get them wrong, don't come crying to me if you didn't check it with an XY chart. Okay, next thing, let's go with a little more difficult kind. Do you remember these? The difference between this and this. Would you make a quick sketch of those two and see if you remember which one's which? Pause while you try that. Okay. By now you either remembered them or you didn't. So, do you get that this is actually the exact same thing as y equals 1 over x squared? And I hope you remember this then is the same as y equals 1 over x to the third. And do you remember that odd and even things look different on the graphs? Okay, and I finally found a way that helps me remember that this kind is the volcano kind. And it's because, oh, the lines even make a volcano. Even. Get it? It's an even one. All right, and then the odd ones, I don't know if you want to try to even remember this, but some people think of this as a butterfly. I'm not totally seeing it, but I guess if you consider like these the wings, and then you could like give them a little, what do they call those, antennas up in front, maybe you can see it a little better, but anyway, however you want to think of this, the odd kind is a lot like 1 over x. Because 1 over x is the parent of all of these, and it's odd, right? X to the 1. Okay. All right. So then, if you remembered those, shouldn't be that bad to graph this. Use your graph again. In second insert. Or not second, sorry. Just for you guys, just insert. Insert graph. This one, I'd like you to compare your graph when you're done with the kid sitting next to you. So do a quality job that you're not embarrassed to show somebody. Most people were done, so I'm going to give this a shot now. First thought is, it's a volcano, so generally it looks like this. Okay, and now I'm going to generally move the thing to the right 2 and then up 1. Asymptotes are going to move with it. So I'm going to draw in my asymptotes with this neato dotted line maker thing. And I'm going to take them and move them where? Right 1. So this goes 1, 2 to the right. If I move this to the right, notice it isn't even moving. So hey, why not just leave it alone? Okay, now I have to move it up 1. Move this up 1. Okay, so now I can see kind of where to draw this little volcano is kind of in here. Would that have been good enough? This is graphing, not sketching, so that would have been wrong. Close, but I would have said you missed the key points. That's a key point, that's a key point. So the graph should have really gone like that. It's not good enough to just have the asymptotes in the right place. Okay, so now that red one, that would have been good enough. Now, notice I didn't check mine. So is there a chance I screwed up? Yep. How many of you actually checked yours with an XY chart? Okay, I made it up to 3 people this time. No, 4. I got 4 people that checked it. All right. Your life, but watch me. How long does this take? I'm going to put in 1. See if it works. 1 minus 2, negative 1. Negative 1 squared is 1. 1 over 1 is 1. 1 plus 1 makes 2. 1 comma 2 should be on my graph. It is. Now I'm pretty confident I'm right. Did anybody time me? It was like 15 seconds to guarantee myself a right answer. Worth it. But up to you. Okay, because it's likely they're going to be a little harder than this when you have to encounter them. All right. Now I'd like to talk about limits for a second. Actually, let's use that same picture, this picture right here, and you'd be able to tell me 4 limits. The left end limit, the right end limit, the limit on the inside as you go from the positives, and the limit on the inside as you go from the negatives. When I say on the inside, what I mean is the limit as you go towards this vertical asymptote. Okay, so tell me the 4 limits you could write about this function. And I'm going to pause, we give that a shot. Okay, in a perfect world, you could just have like a stamp for limits that says this. Because every single limit you write is going to have all those pieces. Every single time. Always. Even when you get to calc. All right, then I have to do stuff to it. So, a second, I'm going to clone this. I'm going to make it an infinite cloner. That way I can just keep dragging them out. Okay, so I'm going to put this as my left end limit. I'm going to put this as my right end limit. Yeah, good enough. I'm going to put this as my inside left, and this is my inside right limit. Oop. And hold on, I'm going to undo my infinite cloner now and get rid of it. Okay, so way right side, do you get that x goes to infinity? Raise your hand if you had that part right. Good. Then, when I get there, when I get way, 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 way to the right, how high is it? Remember, what's over here after the equal sign is how high it is. What do you think? 1 is correct. Because it'll get closer and closer to this asymptote here, which is at a height of 1. So this whole thing equals 1. All right, now the left end. The left end is where x, this is x here, the x's are getting further and further over here, further and further towards negative infinity. And then the answer is, well, this thing's going to get closer and closer and closer to the asymptote, which would be at 1. Raise your hand if you had that one right. Okay, good. And then the inside limits, those are the harder ones. As I'm approaching 2, that's what I'm approaching, not 0. I'm getting close to the asymptote. So I'm getting x to get closer and closer to 2. And I can get that on both of these because they're both approaching 2. And the one's approaching it from the left, which is the negatives, and that guy is over here, and it's going to jump on this track and follow it up, positive infinity. And then this one is approaching 2 from over here in the positives. So it's going to be from a little plus there, and then it would ride in on this track and be forced upwards again, positive infinity. There's my 4 limits. How many of you feel confident on that kind of stuff? Okay, good. One more thing we haven't talked about very much. Could you get that door for us, please? Thank you. Did you know that how many turns something makes tells you something about what degree it is? You got to be careful with this one, but this could not be degree 1. Do you get that there's no way this could be a first degree, as in a y equals x plus 6? You know what those look like, right? What are they? They're straight. This got all kinds of curves in it, so it can't be degree 1. In fact, what you can do is look at how many turns it has and say that this is at least, notice I'm not saying exactly, it's got 1 turn in it, 2 turns in it, 3 turns in it, 4 turns in it. That means it's at least degree, if there's 4 turns, at least degree 5. Okay? Now, why do I say at least? Because there could be something I can't see called imaginaries. How many imaginaries could there be at a time? 2. So it could be 5, or it could be 7, or it could be 9. But do you get how a kid can't draw this for me and then say, well, that could be degree 3? No, it can't. It's got too many turns in it to be degree 3. These are called maxes and mins. It's got 4. Let's talk about some other ones that you know, like this guy. That's probably x squared, but what could it also be? Could be 2 or what? 4 or x to the 6th or x to the 8th, okay? Because you can't tell based on the scale. I mean, maybe I zoomed this in a certain way so it looks like it's x squared, but it's really x to the 8th. So what could I say about it, though? What if a kid said that was degree 1? Can't possibly be right, right? How about if this kid was to say this is degree 3? Can't possibly be right. All right? So it's at least degree 2. Has one turn in it, therefore at least degree 2. Okay, how about this? How many turns does it have in it? Be careful. Some people would just count these two as the only turns. But this is another turn. Because it was going down, and now it ends up going up. It was just a slow turn. Okay? So, it's got 3 turns, so it's at least degree what? 3 turns, at least degree what? 4. Could be 6, could be 8. We also can see that it's even. Both ends are going down. That tells me it's got to be even. But I couldn't say that's degree 2. It can't be degree 2. It's got too many turns in it. Make sense? All right, so don't, when you're making these sketches that you can, make to say, well, this could be my answer, don't throw in extra loops. You go make that. Now I'm going to say, okay, well, that has to, you better have been doing something that's at least, how many turns? 1 turn, 2, 3, 4, 5, 6, 7 turns, so it's at least degree what? At least degree 8. If you're trying to make me a degree 8, that'd be fine. Okay. Last thought, I made up one that factors. Why would you want to factor it? Because it's a lot easier to graph it if you factor it. Factor that. Then graph it. I didn't even say sketch it. Graph it. Okay, so let's see how you did. Hopefully I factored it like this. X comes out, and then I have x squared plus 6x plus 5. And then hopefully you knew how to factor that. X plus 1 and x plus 5. Raise your hand if you had that right. Okay, awesome. Now we know it goes through 3 spots. The roots. The roots here is 0. The root here is -1. And the root here is -5. That one messes a lot of people up. That is important. Just because it doesn't have a parenthesis around it, like this, doesn't mean it's not a root. It's a root as long as it has an x. Now, if it was just a 3 out front, that would not be a root. If it's an x, though, it can be a root. So it goes through 0, it goes through -1, and it goes through -1, 2, 3, -5. All right, now we got to use all our rules we know about these things and say, okay, oh wait, I shouldn't have erased that. I'm going to undo my erasing. Do you get that they all have degree 1? And therefore they're all cut throughs at those spots? If this had been like a degree 2 right here, then it would have been a bounce at that spot. All right, back to, they're all 1s. So is that a possible right answer? Has to go up on the right because it's positive lead coefficient. And has to have a degree 3, which would mean that it's got, let me think. Well, 3 roots. 3 cut-throughs works. Okay. Now, how about the turns that we just talked about a second ago? We really didn't talk that much about that at the beginning, but this has got 2 turns in it, so it's at least degree 3. So that works too. Okay. And it's going opposite directions on the ends. All right. What if I give you one that is factored? I'd like to know what degree is this, what is its roots, and there's however many of them, and then what is their multiplicity, and what do they do at those spots? What's the degree of the whole polynomial? What are its roots? And for each root, tell its multiplicity and what it does. Okay. I was sloppy. I'll clarify that. That is a 5 right there. Pause while you try that one. Okay, so the roots, you should have said -5 is a root. It's not 5, it's -5. And the other root's +3. The multiplicity of this -5 is this part is right there. That's the multiplicity, 2. And what does that do? Bounce. Okay, and then the 3, that's this guy. The multiplicity is 4. And, ooh, that's kind of a weird one. Does that, I don't have a word for that. Snake, or what is it? Bounce. Yes, question? Oh, sorry. Okay. So, any questions on that? All right. So I'm feeling like you're going to be extremely well prepared for this because I think you could have taken both tests on Monday and Tuesday. But I haven't really, I guess bad side right now, if we didn't have an extra day, I haven't even talked about the other test. Okay, and it would have taken me the whole rest of the hour. I had to barely squeezed in everything because all I talked about was a graphing test. So the graphing test, I think that's going to be the easier of the two. Frankly, you guys usually kick butt on the graphing test. So the one we review on Monday will be more important and a little harder. We did do some of that because there's some limits is more of a topic for communications. That's part of the other test, and we did some limits today. So, okay. So there's another review day coming on Monday, and then tests are Tuesday and Wednesday. And that's all I got for today's video.